in order to get rid of the denominators here, I'm going to show this long form. We're going to multiply everything by basically the entire denominator. Okay. Up front, that's a little bit more work than you need to, but it'll help you start to see what's actually going on. Right. So if we multiply everything by 2x, x, and then x plus 1, I know it's, like I said, it's a little bit more than you need, but you'll start to see as things get distributed through why certain parts cancel out, and so on and so on. So if I distribute this whole junk to the first term, I'd get 2x, x plus 1 all over x plus 1. What doesn't that first fraction mean? It doesn't mean the x plus 1. So basically, this winds up being 2x squared times 3x, which is 6x cubed. We okay with that? All right. Same thing for the next one. The next one has the 2x. It needs the x and the x plus 1, which is the same thing as saying x squared plus x. Okay with that? So I'm going to say it's 6x squared plus 6x. I'm distributing the x squared plus x to the 6. And then the last one has the x. It needs the 2x and the x plus 1, which is basically 2x squared plus x. If I distribute that through, so this would equal oh, thank you, sorry. Okay. So then you get what, 14x squared and a 14x? The denominator is gone. Okay with that? Now, when you're solving equations, your objective is to get one side equal to 0, so move everything over. You're okay. Why is it gone? Because we multiplied everything to get rid of it. Remember when we did that before? Even if it was like a 2 or a 3, we just multiply the whole thing. We multiply everything by it, it all goes away. Right? So now I'm going to bring everything over to the left. And we're going to get 6x cubed minus, what is that? 8x squared minus 8x. And it looks like that. Okay. What's your first rule of factoring? What's your GCF? 2x. If I take out a 2x, excuse me, I get, what was that? 3x squared minus 4x minus 4. So far, so good? Now treat it like we did with polynomials. That means 2x. I can set that equal to 0 and get a 0. That's my first part. 2x equals 0. So x equals 0. Can x equal 0? No. That's an extraneous solution. Now I worry about 3 times negative 4. What times what is negative 12? You add together to get negative 4. Negative 6 and positive 2. Just move this up a bit here. 3x and I get x minus 2. Take out a 2, I get an x minus 2. So my two terms then are the 3x plus 2 and the x minus 2, which generates zeros at negative 2/3 and positive 2. And then I just have to go back and check and see, are either of those allowable? I think both of those were okay. And away we go. Let's go. I'm sorry, what's that? Yeah, absolutely, absolutely. I'm just going to start 27 first to show that's easier. That's okay, and then I'll get in 27. 27 is actually a little bit easier. All right, 27 is a little bit easier. The two denominators that you have are the x plus 4, x minus 1. So you multiply everything by x plus 4, x minus 1. First fraction needs the x minus 1. I'll just write it out long time. Middle one needs them both. Oops, sorry, that should be a plus sign. Last one needs the x plus 4. Then we wind up with that. Distribute, combine like terms. When you distribute, we have 6x squared minus 6x, x squared plus 3x minus 4. So I get plus 4x squared plus 12x minus 16. And then this will be 2x squared, 8x, 2x, and an 8. So that's 2x squared, 10x, and an 8. Everybody okay with that one so far? I think that one was easier than the other ones, to be honest with you, because it only had the two denominators. Now again, combine like terms, set one side equal to 0. I'm going to move everything to the left again, because I have 10x squared, subtract 2x squared, I'm going to get 8x squared. Negative 6x plus 12x is 6x, but I'm going to subtract 10 from that, I'm going to get negative 4. I have a negative 16, I'm going to subtract 8 from that, I'm going to get, was it negative 24 then? What's your first rule of factoring? GCF. You got your GCF. From there, it should be relatively simple. I hope. Does that 2 have any bearing on the problem anymore? Nope. It's a constant. When you have the scalar constant, it doesn't make any difference. You don't have to worry about setting it equal to 0. There's no x value given to it. It's just a number. Okay? It's just a scalar, so you don't have to worry about it. I'm assuming you guys can figure out how to factor that and then double check it to make sure the things work. You okay with that? 29 was the next one, wasn't it? 29 is very similar to that method. Okay, it's going to be very similar. I got you. I got you. Can I go to a clean one? I don't want to get too far ahead anyway. It's kind of messy. Just a small amount of this. Also with these problems, it's very, very, very easy to write down a part of one problem and a part of another. Happens a lot. Okay. Here, the common denominator that we're going to multiply everything by is going to be 3x times 2x plus 5. So I'm going to take the whole thing and multiply it by 3x and a 2x plus 5. First fraction needs the 3x, so I distribute that in. And I'm going to get 21x squared plus 3x. The 1 needs both. So I'm going to get 6x squared plus 15x. All I did there was just multiply. I just multiplied this guy out and put it there because I multiplied by 1. And then the last one needs the 2x plus 5. So this needs a
2x plus 5. Boiling that through will get us a 20x squared plus 50x minus 6x minus 15. So that's 44x. Bring everything from the left over to the, the right over to the left. Subtract 20, we get 7x squared.
I just didn't see the 6x.
Oh, it's okay. It's okay. 18 subtract 44, 26. Negative 26. Does that sound right? And then plus 15. Ugh. That's gross, to say the least. You can do synthetic, yeah. You can go, or just use quadratic. Yeah, I don't want to do that. That's awful. I don't want to multiply 135 to get it to 26. That sounds like a very bad day. When I do x equals negative b plus or minus squared. Why aren't you singing? B squared minus 4ac all over 2a. And I'll get my zeros that way. Just using quadratic on that one. I mean, if you want to factor it, or you want to use synthetic. Yeah, that's why I'm using this piece. 26 squared minus 4 times 7 times 15. Oh, it's a perfect square underneath there. It's 16. 6. So that's what? 20. So you do that. And you get the answers. Yay, it's clean. Hooray. Super exciting. Yay. I feel like I should jump into a token. I did that once. You know, your encouragement is awesome. Thank you. It's good high five. What's up? You okay, Adam? What was the next one? 31? That was the last one, wasn't it? So 31 leads us to where we're at today. Actually, so what are you going to do first? Just cross out these. No. Now, here's the deal. You guys have all done this type of a problem. First of all, let me ask you this. True or false? True. Okay. True or false? True. Okay. True or false? True. What we're doing here is we are working with ratios. Fraction equal fraction. Whenever you have fraction equal fraction, you can always exchange-o, change-o on the diagonal. You guys ever heard that before? Kind of like cross multiplying. Now, last year, you did this with trig. When you had the variable in the denominator, all you ever had to do, because this was over 1, was the exchange-o, change-o along the diagonal. And that's what you guys did. That was the shortcut for all of it. You were able to, whenever you had a variable in the denominator, you just switched it along the diagonal. Exchange or change. That's where that comes from. Back to here. It's kinda the same, but without the extra, without having to, you still have to solve them. Now, when you have fraction equal fraction, you were saying a second ago, that's when you would cross multiply. This is that idea of cross multiplying, but you only have to cross multiply along one diagonal, because what's in the denominator of the 4? So what happens here is we wind up with 4 times the quantity x plus 1 is 2x minus 2. I was like, I got it right. You'd be surprised at how many times you guys accidentally just lose your handwriting, or like a 3 becomes a 5 because it's little things like that, or a negative just kind of appears out of nowhere because you thought it was like not completely erased. It happens more often than you think. Right? It's very, very common. And that's, so now here you subtract 2x, add the, or subtract the 4, we get 2x is negative 6. You get negative 3. And then you would always double check to make sure it's an okay answer. That leads us to where we're at today. Today what we're going to be working on are more of these, but it's going to be more along the lines of fraction equal fraction. When it is fraction equal fraction, that's when you're just straight cross multiply. Those are a lot easier. Okay? Those would be a lot easier. For example, we're going to add a couple of these today. What we're doing today, tomorrow, we've got the math team, so I'm going to be out. Then on Wednesday, I have a very short quiz over the these first three sections. Okay? It's like 5 problems. Okay? Yeah. Okay. So now we have. So when you have ones like this, when you have fraction equal fraction, the easiest thing to do is always cross multiply. That's the rule for doing these, as long as there's nothing else tacked on. In this example here, hey guys, we're not on the laptops right now, just so you know. In these examples here, notice how there's nothing adding between the two, it's just straight fraction equal fraction. When you see this scenario, automatically cross multiply. Okay. That's kind of like the alarm bell should be going off in your head because it should be easy. So when you do this with the cross multiplying, we're going to get 2 times the quantity x minus 1 equals x squared minus x. 2x minus 2, x squared minus x. What side are you going to move everything to? You're going to move things to the left, or you're going to move things to the right? I'm going to move everything to the right this time. And why am I going to move things to the right? It's positive. Yep. X squared is already there, and it's positive. So move everything that way. We'll get 0 is x squared minus 3x plus 2. What times what's 2?
Yeah, together we get negative 3.
And you go back to your original problem. What can't your answers be? It can't be 1. I can't have 0. Excuse me. My answers can't be 0. And my answers can't be 1. Why can't my answer be 0? Well, it's not smart. I mean, it's not. It's neither smart nor dumb. It's an inanimate object. It's the absence of value. 0. I did. So the two values, the excluded values for this problem would be 0 or 1. So which one of these do I have to cross off? 1. Yeah. One of those two. Yeah. So you always go back and double check if something is what we call extraneous. Is it an answer? That's not an answer. Okay. And that's where that goes from. Okay. Oops. Take a second to do that one. Now, I see where you're going with that. If you did that, that means you had to do the exchange-o here, right? Okay. That's no big deal. I put all my markers and stuff. Is that the same problem? Yeah. What did I do? No, exchange or change. Flippity floppity, Easter's on its way. Right. But remember, you can whenever you have fraction equal fraction, you can exchange on a diagonal. What's x minus 2 divided by x minus 2? 1. That's one way to do it. If you recognize recognize little patterns, great. If not, no big deal. Multiply, cross multiply. You get x minus 2 times x minus 1 is 6x minus 12. X squared minus 2x minus 1x minus 3x plus 2. Subtract 6x, add 12. Okay. Now, here's the downfall of this. Watch what happens when you did that. What happened to the 2? It's not. It's all right. If you, because in the original problem, if you get 2, what's your numerator? Doesn't that work? So here's the thing. You should never eliminate zeros before you're done. Because you eliminate the possibility of something happening. As much as this would be like a nice shortcut, it doesn't always work. I wanted to make sure you saw that. Always go through the process of doing it the long way. Too many times people will eliminate a value too fast, and you eliminate a possible zero. It's a very common thing. Okay? So always, just cross multiply and go. Because in this case here, 2 would work. You just get 0 divided by 0 equals 0. It would be all right. Let's see, what's the other one? I think I had one more. I wanted to make sure it was in. Yeah, I do want to do that one. What do you mean? I cannot cross multiply. I mean, now here's the deal. Could you cross multiply as like a second go around? If you got your common denominator on the left, then you have one giant fraction, right? But wouldn't it just be easier just to figure out what times what's 20 add together to get negative 12? And that just minus 10 minus 2? Wouldn't you just want to multiply everything by minus 10 minus 2? See where I'm going with that? And that's the thing. Automatically, when you see trinomials, FOIL it. Because you should recognize, ooh, 20s, 10s, 2s, ooh, it should be nice. All right? So you know that if you had that, all you have to multiply everything by is x minus 10, x minus 2. What does the first fraction need? What's the next one need? What's the last one need? Nothing. Part you're going to screw up? Yeah, Bell. No, I was going to say the part you're going to screw up is forgetting to distribute the negative 3 to the negative 10. Yes. Yes. Yep. That would work. Mm-hmm. Yeah, but a lot of times when you see stuff like that, it's not going to be. It's not trying to get you to make it that awful. It shouldn't be like 4-term denominators. It should be something cleanish. Okay. It is possible. Okay. What do we get here? 2x minus 4 minus 3x plus 30 is 6. So 26. So negative x. 26 subtract over is negative 20. You had 20, I believe. You're getting like more and more full. At least you say that. Hannah, you're a good sport, though. I'll give you that. I bet you halfway through she's like, I'm not doing this. Wait, I should do this. Am I right? Yeah. Not so bad. So, let's see, which one? On the same stuff. Yeah, they're real quick. Most of them are just straight across. There's only 2 that you have to do a little extra work with. I have a review sheet that I got to print out, or I don't know how I'll print it or I'll like PDF. I'll just have a PDF. But I'll have the solution guys and everything do that too. So it won't be a big deal. Yeah, tomorrow what we'll do is if you haven't get a chance, make sure you grab the Big Book O answers so you can check your work on this stuff here. Tomorrow I'll have I don't know, maybe like 8 or so, 8, 10 of these things you guys will work on in class when we're out. But it'll be one of those CUDA sheets, so you'll still have the answers and all that to go through. On Wednesday, like I said, I think the quiz is maybe 5 questions, 6 at the top. So there's only, it's, adding, subtracting, multiplying, dividing, solving. So there's really only so many you can do. Thursday, it's not this Thursday, it's the half day, it's next Thursday, right? Okay. So this Thursday, then we have, we will start with our graphing. The way that I'm looking at with just pacing stuff out, today is what? Today's the 3rd? I can change my watch. Math team. Spell. So 9-2. My best, like what we've been saying as far as the calendar and stuff is concerned. For what? Yeah, eventually. Should have it by the end of the week. So when I was looking at the calendar, so you guys know, my best guess is I'm probably leaning more towards the 12th being the test, not the 11th. Next Wednesday is my best guess because next Thursday it's a half day. So I don't want I don't want to have the test on a half day because that would be bad. Or that could be good. Or it could be bad. So did I put the PDF here? Let me put the PDF back on. All right.